and behaves in a way that a lot of scientists says it goes against all the laws of physics. And what happens, it apparently puts out more external energy than internal energy. And if that's true, it could very possibly change the way science works and our thinking about energy in general. Would you welcome, please, Joseph Newman. Nice to meet you.
I appreciate you having me.
I spent a couple of hours last night reading about you in the newspaper clippings and your battles with the patent office and your machine, and it is absolutely fascinating. And I said, hey, if we book him, suppose he turns out to be some cuckoo bird or something who everybody says has come up with a perpetual motion machine, but that is not it at all, is it?
No, not at all, Johnny. In fact, I started on this because I'm just an old country boy.
Yeah, you say you have no training in physics or mathematics as such.
That's right. And I'm just a physical person, and I just don't believe you get something for nothing.
Right.
Okay, and when I was, I think a lot of people are familiar with the plastic covered weights. First thing I invented.
Oh, the barbells with
Yeah.
the plastic coverings?
Yeah.
That's your invention.
And I had designed the equipment to make it. And I just scratched up on a piece of paper, carried it to the machine shop. They'd build it, everybody's made it, things would always work.
Right.
And I said, well, this is what I want to do the rest of my life. Didn't have any doubt about it.
Right.
So I started reading as many books as I could get my hands on. And I picked up a book on energy, read about maybe 4 or 5 pages on Faraday's generator.
Mm-hmm.
And when I read that, I remember squirming around just like I did in school, because they were telling me something. They was telling me they was getting something for nothing. Because they want to say, if you take a magnetic field.
Now, you're going to have to go slow with this for a lot of just
Okay.
pretend a lot of us are chimpanzees. And I remember taking physics in high school and college, but it's been a while. So tell me,
Okay, let me kind of just
start as basic as we can here.
Okay, let me just go real slow with what I saw.
All right.
All right, and I was just, I had no biased opinion.
Right. Now, this is a little horseshoe magnet.
Yeah, a little horseshoe magnet. This is conductor.
Mm-hmm. Copper wire.
Now, what they stated was if you took a conductor, moved it through a magnetic field,
Right.
the current would go in one direction. Say if you pushed it down, the current would go in that direction.
Right.
Okay, and if you pushed it up, then it go in the opposite direction.
True.
And then say if you flipped the magnet over 180 degrees and repeated it, then when you repeated the test, the direction of the currents would reverse.
Right.
And if you pushed down parallel to the lines of force, no matter how vigorously you moved it, you'd produce nothing. And that just immediately made me stir around a little bit.
Right.
And the other thing that bothered me was that if you could move this wire very slowly, basically at a snail's pace, and lo and behold, the current would take off at the speed of light. Now, that was telling me you was getting something for nothing. I'm just an old country boy. Now, I want to know how that was going to happen.
In other words, nothing, kinetic energy could not take off at that speed
That's right.
without something else being there.
That's right. And I've played a lot of sports, and I've never seen that happen.
Right.
And what they state is that it was like the electrons were like billiard balls. When you move the conductor through the magnetic field, they call it an electron. It'd be like it would hit a atom at the end of this wire and push another one out at the end of that wire. But they still had a problem. I shot pool as a kid.
Right.
Now the ball you hit into a stack of balls, the ball that comes off the end won't go a bit faster than the one that hit it.
Right.
So they still had the same problem with me. Now how are you going to get something to go at the speed of light when you move it at a snail's pace? So I had came to a conclusion. I had no biased opinion. I just I wanted the conclusions that they were drawing to match the facts. Their conclusions didn't match my facts. I mean, didn't match their facts.
Right.
And I was just reading it. Okay, so I said, the conclusion I had at that time as a young man was that there was something moving in the magnetic field, basically at the speed of light, and it had some kind of mechanical characteristic that caused the observed results. So I said, I'm going to go down and check and see how you make a magnet a magnet. Now, if I find that the strength of that magnetic field is totally dependent upon the power input, I would know I was wrong.
Right.
But I would know you couldn't get any more energy out of that system than you put into it. But if I found the strength of this magnet was independent of the power input, I would know I was right, that the energy was coming from the atoms of this material.
Right.
So I went to the library, looked it up, I was amazed.
When you say the atoms of this material, you mean what's going on
Internally.
internally in that field, magnetic field?
Yes, and I didn't know how you made a magnet a magnet. But what I said I'd do, I set up a test for myself. And one thing you do when you invent for a living, you don't want to waste your time. You're not going to be successful if you do. So,
Okay, now tell you what, we're going to just have to cut away.
Okay.
Then we'll come back and talk about the test.
Okay.
We tried to prove this out, okay?
Okay.
Okay. may well have come up with some new principle. This is kind of difficult for a lot of us to understand because, you know, you're talking about the magnetism, energy, kinetic energy, and the forces that kind of control the universe. Are what you saying that you may have found a principle that ties those forces together, magnetism, electromagnetism, and...
Yeah, I didn't set out to do that, John. I just set out to figure out how, why, and what of things. And to prove to myself that this energy was a real entity, I had to go through and come up with a unified field theory, mechanically explaining gravity, electricity, magnetism, inertia, planetary motion, and a new source of energy.
Right.
It took me over 15 years to do that. Now, one of the tests I set up for myself to prove to myself that this energy was coming from this atoms of this material.
When you say material?
Yeah, the material, this material is just iron here. And like I said, I set up a test for myself because I wanted to prove or disprove to myself, you know, not for anybody else's benefit, for myself, that I was either wrong or right. So I went down, went to the library, and went to the scientific department, and a young lady very quickly went to the Card Index, gave me about 5 books on magnetism, and I looked it up, and I was amazed how easy it was for me to find it. Now, what it stated was if you took a given volume of iron, say it was this large, and let's say you put X current, this is X current, or X power into this volume of material, and let's say it was made out of iron, it produced, let's say, a very weak magnetic field.
Right.
Okay, then it says if you took off a portion of this, and say mixed it with nickel and cobalt, mixed it all together, you got the volume the same volume, then you put the same X power into it. Now, lo and behold, this magnetic field would become tremendously large. Now, instantly, I knew I was right. Because what it was telling me was the energy didn't come from the energy input. I kept that power the same.
Right.
The only thing I changed was the material itself. So it was telling me then that this energy had to be coming from this mass of this material, exactly as Faraday's tests themselves had shown me. And then I went further. I said, okay, I wanted to find some additional material, and what it stated was it was relative to atom alignment in this material. If you, it said once you reach maximum atom alignment, no amount of power input would significantly increase the strength of this magnetic field. Now again, instantly, it told me that it had to be coming from this material and not the power input. Because if I increase this power by 1 billion times, I would expect this magnetic field to increase by 1 billion times.
Right.
Not true. Once you get maximum atom alignment, the strength of the field would reach a maximum, and that would be it.
It has nothing to do with the internal input.
That's right. So it was telling me consistently. Now, I didn't know how this was going to turn out when I looked it up.
Right.
But it was because I knew my questions were honest questions, not biased questions, honest questions. I didn't care what the rest of the world was saying. I knew I was right because I could answer my own questions, and the scientific community could not answer my questions. And one of the things that bothered me, though, for 3 years was how do you know which direction that current was going? And it's kind of funny the way I came up with it. It dominated my mind for 3 years. The kids woke me up one morning trying to get a wheelie on their bicycle.
Right.
And I was watching the little kids, couldn't hardly get it up. You know, they would get it off 3 or 4 inches.
Right.
And I said, well, if a kid had a bike, would do that to get a lot of fun out of it. So I built an 80-pound flywheel, put it on a 3-wheel bike, and put a positive clutch out of a 30-horsepower motor to it. Kid would get on it, build up that inertia in that flywheel. He'd engage it, run in, come off the ground like that, leave black streaks on the pavement about that long. Kid's eyes would get that big.
Now, let me take a jump ahead here, because you put this, what you've really done, you've produced a machine in various sizes, I understand. Some of them weighing a couple hundred pounds up to like 5,000 pounds.
Yeah, 8,000.
Which produces more external energy output than the internal energy input, right?
Well, yeah, it was kind of worded this way. It produces more energy output than externally inputted into the system. And you're not creating anything. It's the same relationship that I saw on permanent magnets. And prior to this time, it had been taught that a conductor was non-magnetic.
Right.
Because they had compared it to conventional iron magnetic materials. And they said the magnetic field was simply relative to the current input. And that teaching is totally false.
Now, you have a small gyroscope here that we all had as a kid. Explain how this had to do with your development of this.
Okay. Now, what I had on the kid's bike was an 80-pound flywheel. Okay, and I had heard the word that a gyroscope was a stabilizer. And I'd never had a physics course in my life, never had an electrical engineering course in my life. So I'd always go back to the library, do research, and look up what a gyroscope was, and how to make it a stabilizer. And when I looked it up, I went and bought a toy gyroscope, in fact, and not much unlike this. And what I observed, as soon as I started studying the mechanics of a gyroscope, I knew the answer to the question that had dominated my mind for 3 years. How did that current know which direction to go when you moved it up and down in a magnetic field? Why did it reverse? Why is it if you turned the magnet over 180 degrees, it would reverse? Why didn't it produce any current when you went parallel?
Right.
And I'll just try to spin this up. And if you hold this, and if you say you pivot this down, it'll pivot to the left. You pivot it up, it'll go back to the right.
Right.
You can hold it right here on this.
Right here?
Yeah, it'll try to jump out of your hand if you do it real fast.
If I want to turn, it wants to go the other direction, right?
And if you go the opposite direction, you'll feel it go in the opposite direction.
Right.
And the reverse of this is true. If you had this turned over 180 degrees and you repeated it,
right,
then the directions would be reversed. If you push them down, it'll now go in the opposite direction of what it did when you had it on this side and pushed down. And this was the same thing I saw on a conductor. It matched it exactly. And if you push down parallel on this axis, it will not pivot. Now that's exactly what I can see on a conductor. You push down a conductor parallel to lines of force, it'll produce no power, no matter how vigorously you move it. Now what it told me was that there was something moving in that magnetic field, and it had a mechanical characteristic that matched the known facts of a gyroscope exactly. Right. So I knew that that action was a gyroscopic action, that it was moving at the speed of light, and it forward at the speed of light, and it was spinning at the speed of light. And again, when I had came up with this in 1968, I was just totally convinced that I was right. And at that time, I'd been writing to President Johnson in 1967. Every president who's been in office predicting this invention would come forward. I started writing with the Atomic Energy Commission, ERDA, National Science Foundation. They'd say, well, Joe, the burden's of proof on you.
The patent office, I remember, wouldn't even come down and look at it. And you wanted them to come down and pay their expenses to come to your place in Loosedale. And I think one of the statements from the patent office was, even whatever evidence you present us, I think would be unable to give you a patent because your device is incapable of operating, all right?
Yeah.
Which is similar to what they said, if I remember, to the Wright brothers.
Yeah, they said the same
at the time. They said we couldn't give you one because it's impossible for an heavier than air machine to fly, right?
They were saying that 3.5 years after they had flown. They were still saying it. And that's one of the things that I hope to do, Johnny, is to draw a line so that this type of injustice can never happen again. Because the jewel of our civilization is its creative people. And it started off from that point on when they told me that they didn't think they'd ever be able to give me a patent, no matter what evidence I could present.
Have you received a patent yet?
Not in the United States, I have not.
It is patented, I understand, in
Spain and South Africa. But a lot of the other countries are looking to the United States, such as European Patent Office, Canadian Patent Office, Russian Patent Office, to see what...
Do you think your machine, if it can be commercially made available, can, for example, a person would buy a 300 or 400 pound unit and all of a sudden would be able to produce all of the energy they need for their home? Is that certainly within the realm of possibility?
Exactly. I have absolutely no doubt about it. That such a device hooked to a home, a person will never have to pay for energy again. The device will be made smaller. 5 pounds, and they showed that at the Hilton in New Orleans. There was approximately 2,500 people attended, 1,000 people outside, and another 1,500 standing to get in. And it would demonstrate something like 25 times more out than externally and put it into the system.
You're getting more wattage out of that than
what you'd put in. In fact, Railback Battery Company is working with me now trying to design a battery to hold up to this recharging effect of this system. Because not only will it run the device, it'll put more energy back into the battery pack than came out of it.
So you could, that's fascinating. We could stay here all night. We could stay here all night and talk about it, but we really can't tonight. But I wish you well in this. I think it'd be fascinating if it would turn out what you say to be true, because it would do away with a lot of independence on the resources that are certainly not finite.
That's right, and it's going to have a tremendous beneficial effect, and it's my total belief it'll do more toward bringing world peace and all the kings and queens and politicians that live. Congressman Dan Burton of Indiana has introduced a bill into Congress asking Congress to issue Joseph Newman a pioneering patent. So has 4 other congressmen. So I ask the people, if you'd like this invention, call your senators, congressmen, president, demand it.
Joe, I thank you for being here, and good luck with it.